Okay, here we are about to begin adding code into all of our different methods throughout Hyperion so that we can have a functioning game. Now, of course, this isn't going to take place in one video. We're going to stretch this out over a few different videos so that we can break things down and go as slowly as possible. Now, if you recall, in the last video, I told you guys to just relax. A lot of the stuff that we're going to be typing out is going to appear very cryptic to those that are completely new to programming, or even for those that are familiar with programming in other languages but are not yet comfortable working in the C# language. So just follow along, type out what we're doing, and make sure you build your solution often. After each method, try it out, because we've got everything in place in regards to all the methods with them returning the proper types. So anytime you build a solution, it should compile without a problem. And if there is a problem, then you have introduced a typo somewhere close to the area you are working, and it should be really easy to find. Now, again, just have faith in what we're doing. We are going to break all of this stuff down in future lessons, but we want to get a game up and running. Now, in this video, what we're going to do is we're going to focus on 3 of our classes. We're going to focus on the text utils, we're going to focus on our text buffer, and we're going to focus on our command processor. Those 3 classes, we need to go ahead and get some functionality into place so that as we begin adding code into the other parts of Hyperion, we'll have the ability to print some text out on the screen and even process some text that we take in, like a command perhaps, like the word help or something. So we need to get these things in place. So Logan, where do you want to start?
Well, I think we should start with text utils.
Okay.
That'll get some of the foundation out of the way so that commands will go more smoothly.
All right, let's jump on over to text utils real quick. Bring that code up. Take a look at it. Now, if you guys recall, we've got how many? 1, 2, 3 different methods defined. So 3 different actions that the text utils object will be able to do. We have an extract command, we have an extract arguments, and we have a word wrap. Now, as I said, the word wrap is going to be handled at the very end of all of this coding because it is the most cryptic piece of code we have in Hyperion. Now, what are the purpose of these? As Logan said in a previous lesson, extract command is going to extract the command that was typed in by the user when they are playing Hyperion. So as you can see, we are bringing in a string. So we're passing a string in. That string is going to be the string that the player had typed in. And then what we want to do is have some code in here that's going to break that string up and find out the command, the first word that they type. So if you were to type move space west, then we can pull or extract move out and return that. Notice we have a return type in this method, a string. So we can return the word move back and then handle processing that. And the same thing is going to go for extract arguments. We're going to bring that entire line in again, but now what we want to do is we want to return a string, and that string is going to be everything that's going to take place after the first word, which will be our command, a space, and then we have our argument. So that's what we want to extract and send back. So let's go ahead and start focusing on those. I guess we could start with extract command, Logan.
Right. Now we need to, in order to get the command separated from the rest of the line, which are the arguments, where the way the Hyperion works is that you type in the command and use a space as the separating character.
Right.
We need to find that space within the given line.
Okay.
So the first thing we'll do is we'll look for that space, and if we find it, we'll store it.
Okay.
So we'll need to start a variable to possibly store this value, and we're going to call this variable index. And it is going to be equal to line, and we're going to call a method that's found within strings, any string object, and it is index of. We can give index of a character, so this will be a single quote, space, closing single quote, and then we'll end the line off.
Okay. Now, if I can add in real quick, line didn't just pop out of nowhere. Remember, line is a parameter that we have inside of our extract command method. So that's where line comes from. Since line is a string object, it has all of these nice string methods already built in, thanks to .NET. So we can just start using this. So in this particular case, what we're doing is we're saying, basically, look through this string for a space. And if we find a space, return that back. Where is that space at? We're going to return it back into index. And if there is no space in it, it's going to return back a -1, meaning, well, it's not there at all. And then we can work from there.
Right. So that's actually the first thing we're going to check and see if the index is -1, because if it is, then we couldn't find any space and we just need to return back an or an unaffected line.
Right, so basically just give the line back.
Right, there wasn't a space, so we just need to pretend that the entire thing was a command.
And a good example would be if the user had typed help. Help doesn't have any argument, so we'll just send help back to get processed to the command processor.
So in that case, the entire line was the command.
Precisely.
So we'll say if index is equal to -1, then we simply return the line, the entire line.
Okay.
Otherwise, so else, that means there was some space found. We need to return all of the string up until the space, but not including the space. So in this case, we would need to return line, again accessing line as an object and calling one of its methods, this time substring. And substring takes in, the overloaded version we're going to use takes in a starting index and then how many characters after that index to return. Well, since the command is the first portion of the string, we're just going to start at 0, start at the beginning of the string, and then return up until that index. So we should be able to drop our index variable in right after that, and that should take care of it.
Okay.
And as a matter of fact, that's pretty much it for extract command. Again, just returning the entire line in case that it was a simple command with no arguments, or the command only if there were arguments, so if a space was found.
Right.
Alright, I guess it's time to move on to extract arguments. And this is somewhat similar to extract command, it's just the other part of the string. If there were arguments, return those arguments.
Okay.
So again, we'll create an index variable to hold the value so we don't have to keep looking it up over and over again. And that index will again be line.index of.
So once again, let's look through the string for a space.
And one note, as I'm using index of, I'm using the method that takes in one char. And char is indicated by single quotes instead of double quotes. You saw earlier when we had the return blank string, we were using double quotes. Also elsewhere in code, when we used strings, we use double quotes around strings. And in chars, we use single quotes. So make sure you use the right quote for the...
char is just another data type. It's a single character, like the letter A, or a space in this case. So again, we're going to do the exact same thing. We're just going to check our index and see if our index is equal to a -1. That means nothing was found.
Now, if nothing was found, we want to return just a blank string, because that means that if there was no space, then we can assume that there's no arguments in the string at all. So we will return blank string.
Okay.
And again, double quotes versus single quotes. I'm just pointing that out because if people are following along line by line and character by character, it could be easy to confuse a quote and then spend some time figuring out what's wrong. All right. Otherwise, if we did have a space within the past line, now we need to use substring again, but this time get everything after that space. So we will return, and then I'll start an opening parenthesis, line.substring. Inside of that, now we need to feed it index, so we start at index. And we need to go
1 over, because we don't want the space.
Right, if we start at the space, we'll be including the space character. We want to go to the character that happened after the space, which is the start of the arguments. So index +1, and then how far do we want to go? Well, we want to go to the end of the line. So this would be how many characters? Well, okay, this is a little bit tricky. Let me go back. We need to tell it how many characters after the index we want. That can't be the length of the entire string.
Watch this, Logan. Okay, I promised I wasn't going to do this, but I can't help it. It's killing me. If I was to come over here and, let's see, make this a little bit smaller. How about even smaller than that? Yeah, somebody was using my computer earlier, Zach. And we had some characters, like move east. Well, we've been interested in this area right in here to help us figure out where our command is and where our argument is. And now we're using that nice little substring to find out where it is or what part of this entire string we want to send back. So we need to tell it where we want to start. Well, 1, 2, 3, 4, 5. All right, so right here was our space. Remember how Logan did +1? So now we're pointing right here. So we want to start right here. Now how far do we want to go? Well, we just want to pick up this guy, and this guy also, so that we have all of these guys to send back, right? Well, how do we do that? Well, what Logan's going to do is he's going to get the entire length of this, and then he's going to subtract away this part right here, and that's going to leave us, ta-da, with that. Does that look good?
Exactly.
All right, so now how do we turn that into code?
All right, let's jump back in. We've already gotten our position of the space +1, so there would be the E character from the whiteboard example.
Mm-hmm.
Now we need to move 4 more characters in that case, or overall length minus the index itself.
Right.
So overall length is line, or can be found in line.length, and then we'll subtract off our index value, and then we'll subtract 1 more to account for the fact that we've moved over. We're using, we're one over that space. Again, it goes back to whether we include or don't include the space. Because of this, we're not including the space. That means for the overall, we also need to not include the space on the other side. So we'll have line.length minus index minus 1. And then 1 more closing parenthesis for, as a matter of fact, we don't even need these parentheses around the outside. We can just end it off there. So return line.substring where we take in our starting position at the index, and our number of characters, overall length, minus the position of the index, minus 1.
Okay, now let's go ahead and build and make sure that we're building with no problem. And so far, so good, no errors at all. Now, if you wanted to real quick, could they test this out?
I mean, they could run the code. This code that we've just written has no bearing because nothing calls it yet.
I know. You're not necessarily a big fan. It's probably to show them they could do this. If we want to jump back over to program real quick and just call, since TextUtils is a static class, the object exists right off by default. So right above the show title screen, since that's going to hold it up for us, we could just go ahead and call TextUtils.
So looking into here, yep, we have TextUtils.
And this can be neat because I'm going to have you write it out first, then go back and encapsulate that into the right line. So we've got TextUtils, and then we've got extract command. And then it's expecting a string, so double quote until it moves space east, in quotes, and that, and terminator. But now, if we run this right now, go ahead and run it. All right, well, great. We didn't see our command, which should have been moved. Why didn't we see it? Because we're not writing it out to our screen. So let's put this inside of a console.write line. So now what gets returned will get written out. So let's give this a shot. Oh, the command is move. Fantastic. Now let's go ahead and close that and simply change, instead of extract command, let's extract argument. And try that. And east. Ta-da! So if you guys want to test this out, there you go. Piece of cake. And personally, the way I like to code, I like to test stuff out as often as possible. And sometimes Logan, all right, most of the time, likes to put a whole lot of stuff in at one time. And I understand everybody has their own styles, so I'll probably pester him just for you guys from time to time to test stuff out when it's really easy to test a particular method out. Cool. Okay, everything's working.
Alrighty. And now that we've proven all that, I'm going to take the lead of the line back out.
Logan's not leaving that in, that's for sure.
Alright, well that takes care of the TextUtils.
Sweet.
Now we can move on to text buffer.
Real quick, go back to TextUtils. Let's just remind them, in TextUtils, there is, if we scroll down, there is the good old word wrap, but as a reminder, right now all we're doing is we're passing in our text and the buffer width, which we'll talk about later, but our text is coming in, and we're just going to return that text right back out. So this is just a pass-through method at the moment. At the very end, we'll come back and add all the fancy details. So with that in place, that is truly it for this class.
All right. So we'll move over now to text buffer.
The text buffer.
And we have
2 methods, add and display, where we're going to add stuff into our output buffer, and we can call display to basically shoot it out to our console.
All right. Now add is going to be very simple. Add is simply going to take our internal output buffer and add the incoming text to it, which is simply output buffer. Let me take the whole thing out. Buffer dot. As a matter of fact, not even dot, we're just going to take the entire output buffer plus equal whatever text we had. Now we're also going to add onto the text a new line character, so \n. This is just for the way we're handling display, as in it's going to be expecting whatever to be coming into add to be displayed as a line. So it'll take that text and then continue on to the next line, take all of that and put it into output buffer.
Oh man, that might be confusing for those of you out there that are beginners in here. I just can't help it. I've got to grab my whiteboard pen one more time. I just want to spend 1 second and take a look at this. What may be a strange combination of symbols to those of you that are new to programming. Let's go ahead and jump over here to our fancy whiteboard. Whoa, that's all kind of scary looking. Let's just quickly come in here and give you a quick warning. No, I don't want to give you a quick warning. Let's actually flood this again. Didn't mean to delete all that and scare you and me. So, real quick, what is this plus equals that he's using? So let's go ahead and switch back over real quick. So we're taking output buffer plus equals text. All right, so what does that mean? So let's just call it OB for output buffer plus equals text. So I'm just simplifying everything. What this actually means, this is just an abbreviated way of doing this. Output buffer equals output buffer plus text. So let's talk about variables again. So basically, here's a variable over here in memory that's called output buffer, and in it, let's say it has a cat, the word cat, not a real cat. And then we have another piece over here that is called text, another piece of memory, a variable. And inside it, it's got dog. Yes, indeed. When this line executes, what happens is, since this contains cat plus dog, if you combine these two, this is concatenation. Ooh, big word, head hurts. What we're doing is we're simply appending this to the end of this. So we end up with cat dog. New superhero. And that is what is, through our equals assignment operator right here, that is what is being put in OB. So what ends up happening is, after this command runs, instead of cat existing in OB, well, I didn't mean to do that. That's what happens when I just come through here quickly. What ends up happening is, instead of there being a cat in there, cat dog is what is in there. If the very next line of code right here, we say right line out whatever's in the output buffer. It's going to say cat dog. So that's what's going on. Anytime you see this plus equals, I just wanted you guys to understand that it's saying, all right, OB plus equals, that means take what's currently in this particular variable and add to it. And you can also see minus equals, divide equals, times equals. Those are all possibilities that you may see throughout the code that we're going to do. But that's what's going on. It is just a shortened way of typing this all out. It allows us to not have to retype the variable again when we're wanting to start out by taking what's currently in the variable and adding something to it. Okay?
All right, again, just shorthand for variable equals variable plus. Can just be shortened down to variable plus equals.
And you'll notice he's concatenating a \n, an escape character to it. Basically, a \n is a special character that is telling it to do a new line. So it's putting a new line there. So it's as if we added that text in the output buffer, and at the end of that text there was the enter key was hit. So I just wanted to throw that in real quick too.
And I guess we could keep with our practice of doing a quick build to make sure that everything is still happy, and it is.
Okay.
So now we can move on to display. Now, inside of display, we want display to take, well, to begin with, take everything off the screen and clear it, then write out the output buffer, add on that extra text that happens before every prompt where the character or your player in the game says, what shall I do?
Right.
And then puts the little forwards or greater than sign for the actual text buffer. So the first thing we need to do is do a console.clear. Then we'll write out whatever is currently in the output buffer, but there's a special way we're going to do this. They'll begin simple enough with console.write. So already it's a little bit different, write instead of write line. Now, what do we want to write? Well, we're going to write out something that is word wrapped. So we'll call upon text utils.wordWrap, and into wordWrap we'll take whatever is in the output buffer. So out, if I can type, output buffer. Now, wordWrap takes in 2 arguments. It also takes in a buffer width. How wide is the screen right now? And we have a value we can fill into that. We can get the console's current width. That's accessible from the console.width window width property.
And this is going to be really important because later on, when we make word wrap actually work so that all of our words don't just get chopped at the end and start on the next line, which looks awful and it makes reading very difficult, it's really important that we know just how wide that console window is, how many characters can fit on there. And that's why we're going to be sending it over so that when we go in there and write our word wrap routine, we know how long it is at that point.
Right. So let's see, that's the closing parenthesis for word wrap. One more should close off for the console.write, and then we can add a terminator. Now in the next line, we're going to write out the what shall I do line. So console.write line, what shall I do? Now we're going to add that little caret character thing to make the buffer look a little bit better, which will be console.write. There's using write again, and we'll add a greater than sign. And we're using write on this one just so that the prompt will be sitting on the same line as this right now.
Yeah, actually, just real quick, I'll just tell them that basically write line is going to be as if you had typed some stuff out to the console, or your program had typed some stuff out to the console and hit the enter key. That is a full line. Write just simply writes some stuff to the console, but the enter key is never hit. Well, check this out. What are we writing to the console? Well, we're writing the result of what word wrap is sending back to us. Well, right now, what is word wrap sending back to us? It's sending back to us whatever we send it. Remember, we said that over here in text utils, word wrap is going to just serve as a pass-through method at the moment. So whatever we get in, we send back. So let's say we type in, up. Up goes in, up comes back. So we're going to write up out. But remember, what is an output buffer? Well, let's bring our attention back up here to add. Every time we add something to output buffer, we're always putting a new line at the end. That's why we're doing write as opposed to write line, is because we are making sure that is indeed a write line in the fact that an enter was added to the end. So that's why it's going to wrap on its own. It's going to be a line break, start a new line. So that's why we're doing that. And then down here, as Logan says, we're doing a real write line here because we're going to have the next line write out what shall I do. And since that's a write line, pretend you hit enter at the end here. So now we're down up underneath that on the console, and it's going to write out this little symbol right here, the greater than symbol, kind of like a prompt. But since it's just a write, not a write line, there is no enter. So our little flashing cursor is going to be right next to this. So it's like a prompt waiting for the user to type something. Okay, but this isn't actually waiting for the user to type. This is us just creating a prompt so that the user says, hey, that's a prompt. It's waiting on me to do something. Okay?
All right, and that's the stuff we need to do for writing out to the screen. Now, the last thing we need to do is, because we've just run a display, this needs to clear the internal buffer, which means taking output buffer and setting it to be a blank string, so clear all of the data out of output buffer.
So as you can see, this whole text buffer thing is all about output buffer. It's all about us storing text in here, adding it in, and then printing it out. And when we print it out to our console, we're going to clear it. So then we're adding new text in. Okay?
All right, now we'll try a build, make sure everything is still happy, and it is.
Okay. So there we go. That pretty much wraps up the text buffer.
All right, now we move on to the command processor.
The good stuff. Oh, yeah.
All right, let's load up the command processor and begin with our process command.
It starts so simple. We only have two methods.
Yeah. All right, let's see. Process command. The first thing we want to do is we need to take the incoming line, use our extract command and extract argument methods, and store variables for those so that we can use those values later throughout the method to decide exactly what command was run and if some arguments need to get passed down along the line.
Okay.
All right. We'll start with a string variable called command, and that will be set to whatever the incoming command portion of this line was. So we need to access our text utils, and we need to tell it to extract a command from the incoming line. Now I'm going to type this out, but I'm going to enhance it a little bit after I do. That alone would work in most cases. Now, the tricky thing is I want to have this set up so that it always trim spaces off of the line in case there were spaces after or before, just to make sure that the user doesn't type in a command and then a space and not understand why his command doesn't work.
Right.
So before we feed this line into the extract command method, I'm going to tell it to trim itself, so give the trimmed result. And what trim is going to do is trim any white space, and then in our case, spaces off of that line. So we're going to give the trimmed result of line into the extract command, and then after we get that result back, we're going to take that and trim it as well. So in case any spaces were introduced, as in if we cut the end off but there was still a space because of the space between the command and the line. So we're going to trim going in, trim coming back out, and then after we trim, we're going to have it cased to lower. So take the entire result, add dot to lower, and that should end off the line. And the reason we're doing that is so that all commands can be handled as lowercase internally. That way we don't have to worry about uppercase east versus lowercase east.
Right.
After something is typed in, we can always assume that it's lowercase.
That way they can just type whatever case they want. That second dot trim, Logan, makes me wonder. I wasn't paying very close attention to your logic, but are you sending a space back every time when you're pulling out the command?
Oh, I'd have to test it to see.
Okay.
It technically might not even be necessary. This is just the code we had finalized for.
I got you. Sounds fantastic, but it works. So if there's a space coming back. So now we need to get our argument.
All right. So the arguments, let's store those as a variable first. Arguments will be equal to textutils.extract arguments. And then the same thing, we have our line, but we want to trim spaces off it, so dot trim. And then take the trimmed result, just in case there are any more spaces. And then finally, case that to lower. And that'll finish off argument. So we have the command stored and the argument stored.
All right, so now that we've broke them apart and we have the command and the argument separated, now we can go ahead and start making some determinations. What is it they want to do?
And this is going to introduce a switch, so something new. We'll have a switch based on the command, and then we'll block the switch in. Now, inside of a switch, we need to set up for a series of possible cases that can be possible values for a command. So the first of those is going to be exit. So we'll do a case for exit, and if exit was in fact a case we encounter, we'll drop down and we'll do the following. We'll tell the program that it needs to quit, and then we'll return from this entire process command method. Now this is one thing that hasn't made it into our skeleton yet, and that is I want to have some way of marking the program as to whether or not it should keep running.
Okay.
So that means we're going to need a variable back in program. So I'm going to jump over to program for a moment, and then inside of class program, just above the main method, I'm going to start a public static boolean called quit. And I know this is a little bit messier or unsafe than setting up a property for program, but again, it's a very simple value, and it doesn't really need any access protection because we want anything to be able to cause the program to exit very easily. And even though it should default to false, I'm actually going to set it up as false to begin with. So now back in the command processor, if exit is typed, we can take our program, tell it that it is ready to quit, so quit equals true, and then return from the entire process command method. Now, before I get the, let's see, I guess we can just go down the line and type all these out.
Yeah, I say why not.
Alright, let's actually tab back a few. Another case could be the help command. So what to do if help is typed? If help is typed, then we should use our show help method from within the command processor. So we'll simply call upon show help. And in this case, though, instead of returning, we want to go ahead and fall through to the very end of process command, but we do need to break out of the switch so that no other cases are hit. So I'll type break, and then if that means if help is indeed caught, then no other cases will be handled.
So what you're doing is you're setting up with this switch thing here. I'm just going to call it a thing for our beginners out there, right? So what we're doing is we're setting it up in such a way that in case exit comes in, it's time to quit. That's it. There's no reason to hang around. We're going to get out altogether. That's why you return back out of the process command right there, and we're going to end back up in program where we'll be able to actually exit the game. But with everybody else, you're going to break out so that we can add more code at the end of the switch. So after we've processed the particular command, like in this case, you just typed case help, and we're going to call the method show help, which as everyone sees is actually below. It's inside our command processor class. But then after it comes back from calling that method, it's just going to break, meaning jump out of our switch right here, just so that we can finish doing any additional code we want in our process command. So keep that in mind. You'll see where that's going to come into play in just a minute.
Right. All right. Well, moving on to the command after help, next command is move. So we have case move, and in that case we should call upon the player and tell the player to move in the given direction. So where does the given direction come from? Well, that would be the argument. If we had typed move space east, east is the direction we need to feed to move. So we'll add our arguments into move and feed that over to player. And again, this is another case where we want to break after the move command. And then we'll do the next command, which is look. So case look should cause, actually let me go back and add my the colon after that. For look, we want to call upon the room that the player is currently in and tell it to redescribe itself. So since we have no way since we access what room the player is in through the player itself, we actually need to ask the player what room it's in. So player dot get current room, and it's a method, so we have to add the opening and closing parentheses, dot describe, which is also a method, so we need to have more open closing parentheses. So a little bit trickier, a little bit deeper than some of the other things, but again, once we get the current room, we can look at this entire thing as a room, which can be told to describe itself.
Right.
And then again, we need to break after that.
Again, just breaking out of the switch.
So moving on to the next case. All right, next command is pickup. So in case of pickup, we need to tell the player to attempt to pick up whatever arguments we had typed in. The player dot pickup item, and then pass it arguments. And break. The next command will be drop. And drop needs to tell the player to attempt to drop whatever item we're giving it. So drop item for arguments.
Hopefully at this point everybody's starting to see how convenient it was for us to kind of plan out the game, figure what objects we needed to actually have, then code all those objects in, and then walk through each of the objects and kind of think about what kind of functionality, what kind of actions do they need to have, and go ahead and put the skeletal structures for those into place. And now we can just start kind of walking through it, adding code in, and everything works. IntelliSense is telling us that, hey, pickup item is there for player, drop item is there for player. It's looking for you to send some sort of string to it, so everything's working quite conveniently. Now, of course, in the real world, you're not always going to hit every single action in the planning phase, dead on. You're not going to get every method. You're going to find yourself having to jump back and forth between classes from time to time and adding methods in, especially if you don't do a really good job planning things out. I just wanted to point that out real quick. It's been very convenient having the skeleton in place.
Right, because that way we can focus on classes one at a time and not have to jump as much.
Right.
Because just a second ago when I had to jump around to add the quit in, imagine if we had to do that for every single command as we're adding them.
It could become confusing.
But, alright, continuing on, we've got the inventory command next. So we'll say case inventory. And if the inventory is run, we need to simply ask the player to display whatever its current inventory is. So we have display inventory. And break. And the next command is where am I? And in this case, we need to get the room again, just like we did for describe, only this time we need to have it show only the title of the room. So we'll ask the player what its current room is. So we'll tell it to get its current room, and once we have that room, we can tell that room to show its title. And again, we'll break after that. Alright, the next command we've got is, well, actually, that's it for the handleable commands that we have so far. There's just one thing left we need to add into this switch statement, and that is a default action. What action to take if none of these commands, or if none of these values are what is stored in command. So if command was not exit, help, or so on, what should be done? And for this we'll have a default case. So we'll type default, and then a colon, jump down. Now for default, we need to say that whatever was given was not a valid input, or we'll just tell the user that input was not understood. So we'll take our new text buffer object, and we'll tell it to we'll tell it to add, not displaying yet, tell it to add some text, and this text is input not understood.
And of course it's not understood because we didn't find any of the commands that we did understand. So you can see where you can easily come in here and add more commands just by adding, let's say right after the case, where am I? And right before default, you can add another case. It could be something like use or scan. You could say case scan, and then you could perhaps inside the player have a scan method set up. And then you could send it the argument of what you want the player to scan, just as an example.
Right, anything you want to add on. If you decide to add more functionality to a player or room or anything, and now you decide you want to have a text command access it, basically you'll be taking something that looks like these 3 lines, making a new case for your new command, and then causing something within the code to happen. Right. And then, of course, breaking out so you don't process every single case at the same time. But after that, we've got our default now. So we've got default. We're telling that in the default case there was simply no understood input, and then we're breaking out of that to end the switch. So let me take out this last line, and we should be able to build just to make sure that we've got our switch and our command and arguments running. So I'll build, and everything looks good.
No errors whatsoever. Now, do you want to go ahead and add these in here and show them why we're breaking out so that we hit the last 2 pieces of the command processor?
Sure. Let's jump.
See, at this point, we've done a command. Let's say we've done a pickup, we've done a drop, we've done a move. Now, what would be the logical next thing we'd want to have happen? Well, we'd want the game rules to apply. So let's say if we dropped the green ball in the green room, we win. So we just issued, let's say, a drop command, and we dropped the green ball, so the player drops the green ball in whatever room he's in. Then we're going to break out, but we are still inside of the command processor method. So we're still inside here, okay? So we break out, meaning we come right outside of the switch. So right down here, the very next thing we'd want to do is go ahead and tell it to apply the game rules just to make sure that dropping the green ball in that room doesn't cause us to win the game. Because in my little example I just said, it does cause us to win the game. So you'd want the game to say, hey, you won. So this is the perfect place to check our rules right after we did an action.
Right, because any of those actions are everything that could possibly change the state of the game.
Right.
So after the state has possibly been changed, we need to call our game manager and tell it to apply rules. Now, after the game manager has done anything it needs to do, which could possibly end the game, could possibly win the game, or could possibly do nothing. You could have dropped the green ball in the blue room, which would have no effect. So that's one possible scenario where nothing could happen. So if that is in fact the case, we need to go and take whatever output has been collected in our text buffer and display that. So we need to tell our text buffer to go ahead and display whatever it holds.
Yeah, all of these other commands could have been adding into the text buffer, like you just moved into this new room, etc., etc. Here is even a really funny one. I mean, we just said we have no clue what it is you just said to us. Then we come down here and apply rules, then we display that you have no clue. Well, check this out. Why is this here and then not just saying dot display and break out? Well, we could come in here and enhance the game a little bit. You could say each time somebody types something we don't understand what it is, we could, if we wanted to, in expanding the game, add another property to the player for something like, how many times an unrecognizable command was typed.
Number of text errors.
And then in apply rules, you could check that, and you could say if the player has typed 50 different commands that we didn't understand, then the game rules could come back and say, you've been drinking today? You're having a really hard time typing in commands, aren't you? And you can make the game a little funnier that way. So we are set up in a position to do that. So I just wanted to kind of point out some of the logic there.
Right. And another reason that text adding is handled separately from text displaying is that some of these things that we do throughout the game, like moving around, might in turn tell a room to describe itself. That might in turn have a few more things need to be added to the text buffer. We want all of that to happen before we display. So that way that gives the chance for multiple objects to add things to the text buffer before anything gets shown.
Exactly. Very nice. And that wraps up the command processor. Blah. The command processor method has now been wrapped up. Thank you very much.
The process command.
Command, that's it.
So with that method done, let's build one more time, make sure that everything is good.
Okay.
And now we can move on to the show help method.
Okay. So show help.
All right. All show help is going to do is show a list of available commands. So really fairly simple. We've got, now we're going to be using our text buffer.
Heavily.
I'm going to add to the text buffer. We're going to add some text. And this will be starting off with available commands. And let's see, just the casing. And then close that off. And we'll add some more things to text buffer. We'll add a line underneath that just to have a little bit of text separation between these. And we'll have, let's see. All right, now we get to add the text for the first command, which is help. We've got a help command. And now to make this a little bit easier to type, I'm going to grab this.
Yeah, I was about to say I have no objection to a lot of copy and pasting. I'm sure they can follow along.
Simply copy, paste, then paste again to add, which will end up becoming our exit, our move, our look, our pickup, our drop, our inventory, and our where am I commands. So jumping back up to second, we have exit, we have move, and then we'll also hint as to which directions you can move. So we'll put in brackets north, comma, south, comma, east, comma, west. And let's see, we have our look command, we have a pickup command, we have a drop command, we have an inventory command, and finally we have the where am I command.
Now check this out. This is really kind of nifty here. And that's it for this method. But notice there's no new line after all these. At this point you can kind of really start to piece together everything that's happening. When we come through our command processor, I keep wanting to flip that word around. When we come through the process command method and we take in our line, which may have been help, what happens is we come down here first and we're going to extract the command from, well, the line, which contains just the word help. So from over here in text utils, we get up here in extract command, and what do? We find out that, well, there is no spaces in just help, so we send help back. So now we come back over here to our command processor, back in the process command method, and now we simply we go over here for arguments. There are no arguments. And we come down here to the switch, and what's being stored in command? Well, remember, help is being stored in command. So in case it's exit, nope. In case it's help, oh yeah, it is help. Okay, fantastic. Let's call upon the show help method, and remember where we're at. So we're here. We're going to jump down and do show help. Here's show help. Let's add to the text buffer. Available commands, all right? So text buffer, when we call add, we're sending in available commands. That's what's sitting inside here. Well, we're starting out with our output buffer being empty, so we take empty and we add to empty available commands, and then we hit the enter key basically. All right, so now that's it. So that's the end. So now we're going to return back over here to our command processor, and then we're going to hit the next line. So now we're going to do text buffer, add a bunch of lines. And then, again, same thing. So text buffer comes over here. We send a whole bunch of lines in here. And now we're saying output buffer, which is currently available commands with an enter key at the end. We're now going to add to that, What's coming in? A whole bunch of lines. So now we have available commands, enter, a whole bunch of lines, enter. So now we're basically compiling a list, and we build that list, as you can see, all the way down here to the very last one. When the very last line gets appended into the text buffer, then we hit the end of our method. When we hit the end of our method, we return back to whoever called show help. So let's come back up here to our process command method. This is where we called show help. So we come back to the next line, which is break, which means we're going to break out of our switch. So find the end of it. So we're going to break out of that, which means we come down here to our game manager. So we do apply rules. So we check for anything happening that needs to win, lose the game, etc. And then we come back and we say textBuffer.display. So now this is very important. Now we come back over here to the text buffer again, and we call display. Well, what does display do? It clears our console, and then it writes out, basically, in most simplistic terms, it writes out what's in our output buffer. Well, we're inside the text buffer object right here, and what's in the output buffer? Well, we've been adding over and over and over all of these different commands. So what happens? That gets written out to the console, and of course the very last line in it also had a new line, so there's an enter. So up underneath that we get a what shall I do? And then up underneath that we're going to have our little greater than symbol as our prompt. And then from there, we clear our output buffer because we don't want all that help information sitting in the output buffer. So we clear it, and then we return yet again. So we return back over here and check it out. We're now at the very end of the process command method right here. And so that's it. Now it's time to wait for another command to be typed by the user.
So already an impressive list of actions that takes place
Absolutely.
at any given time. Well, now that we've got the command processor, we can do something else that's interesting. We could take the command processor and put it into action back in program.
Sounds good to me.
So let's jump to program. And right after the show title screen now, let's call upon it.
We don't have anything actually holding it up yet.
We should, though, if we had this thing, because I mean, the processing of commands comes after the title screen.
Okay.
So, check this out. What we're going to do is, before we even get to process command, is we're going to begin a loop. Because
you're going to put the loop in. Okay, I'm cool.
Right, we're actually putting in the real version of...
Dude, guys, if you could have seen the look on my face and the look on Logan's face when he saw the look on my face, you guys would have had an interesting look on your face, because I'm thinking he's going to call on command processor and send it something like help, but it's going to flicker after we hit the enter key from the show title. Okay. I was like, I don't remember the loop, but he's going to put a loop in. Excellent. So this is our game loop right here, the heart of our game.
Exactly. That's what we're starting. We're going to start a while loop, and we're going to say while quit is equal to false. And I'll probably shorten that here in just a second, but this would be a little bit simpler for the first time we write it out. So while we're not quitting...
Highlight that quit above to remind them where quit comes from.
This is the quit variable that we had created before we went into the command processor, or while we were in the command processor.
Okay.
So while we're not quitting, we want to, and just I guess for clarity's sake, I'll actually begin an end block, even though we don't absolutely have to for this one.
So the code inside this block belongs to that while. It's going to be the looping code.
So while we're not quitting, we want to process commands. So we'll call upon the command processor. We'll tell it to process a command, and that command will be whatever was entered, which means we need to get a line from the user. We need to read the line from the console. So we'll access console.readLine and feed that to the command processor. So this is actually where we'll be holding up after the title screen. We'll wait until a line is read in. We'll then take that line and feed it over to the command processor, which will have any number of things happen, and then we continue on as long as we're still looping.
And then, of course, in the command processor, for the text that you had typed quit, back up here, it's going to set programs.quit to true and then return us back. So that'll send us back over to program. And then, well, we come back up in our while, and quit is now true, so we're going to fall out of that, and that's the end of the whole program.
And I want to clean this up a little bit. In this case, adding the not operator actually makes this a little bit cleaner to read. I know we haven't introduced it formally yet, but this will simply reverse any Boolean value. So while we're not quitting,
you're right.
we continue running. And it does, if you read it out like that, it does kind of make sense. So let me do a build, make sure that I haven't introduced any errors, and I haven't. So I'll run, will show our title screen. If I press enter now, it doesn't look like anything has happened yet.
That's because we haven't yet called the display so that we put the caret in there.
Nothing gets displayed, but if I were to type help...
Now we're going to kick it all off.
Ooh, we've got the help command and the what shall I do.
Yep, very nice. And so it's flashing. And let's see, and you can type help again, and it'll print it out again, clear the screen and print it. Now if you type quit, it'll actually quit.
So if we exit out...
Oh, yeah, exit. My bad. I'm quit. Yeah, the command is exit.
So those are two commands that are actually working, and the command processor itself in place for real this time. So you saw we actually went in, we ran the help command, then we ran the exit command, and everything is working.
Beautiful. So I believe this is everything we were looking to get into place in this lesson, right?
Yeah, that'll do it.
Okay, so make sure, as you guys are following along, that you have everything functioning all the way up to this point before getting really excited and jumping into the next video and giving yourself heartache because everything wasn't working in this video. So make sure everything works, builds nicely, and that you were able to do the exact same example Logan did at the very end right here with the while loop, because again, that is our game loop. And once it all works, progress forward into the next video. So thanks a lot.